You already know that subtraction is not associative for whole numbers and integers. What about rational numbers? Let us understand this with the help of this example. So let us check, is left hand side equals to right hand side or not? So first we will solve the left hand side. On left hand side we have the brackets. So as per the BODMAS rule, first you need to solve the brackets. So let us write it down. So on left hand side we have minus 2 by 3 and this minus sign I am writing as it is. Then denominators are different, so you have to make the denominator same by taking the LCM, and the LCM for 5 and 2 is 10. So here you have to multiply both numerator and denominator by 2. So what you will get? Minus 8 by 10. This minus sign I am writing as it is. Here you have to multiply both numerator and denominator by 5. So you get here 5 by 10. Now let us solve it. So here you get minus 2 by 3, this minus sign as it is. So minus 8 minus 5 is minus 13 upon 10. So minus into minus is plus. So this minus 2 by 3 I am writing as it is. This minus into minus is plus. So this is plus 13 upon 10. Again the denominators are different. So you have to make the denominator same by taking the LCM. The LCM for 3 and 10 is 30. So here you have to multiply both numerator and denominator by 10. So what do you get? Minus 20 upon 30. And here you have to multiply both numerator and denominator by 3. So 13 into 3 is 39 upon 30. Now you can add them easily. So minus 20 plus 39, you need to find out the difference and sign of the greater number. So the greater number is 39, so it will be positive. So 9 minus 0 is 9 and 3 minus 2 is 1. Sign of the greater number is 39, so it will be plus here upon, so 19 upon 30. So you solve the left hand side. Let us see what do you get on right hand side. On right hand side we have this inside the brackets first. So as per BODMAS rule, first you need to solve the brackets first. So LCM of 3 and 5 is 15. So here you have to multiply both numerator and denominator by 5. So what will you get here? Minus 10 by 15. So here you got minus 10 by 15. Then this minus into minus is plus. Here you have to multiply both numerator and denominator by 3. So what will you get here? 12 upon 15. And then this minus 1 by 2. So what will you get here when you solve this? Minus 10 plus 12 is 2 upon 15, and here minus 1 by 2. Again the denominators are different, so you have to make the denominator same by taking the LCM, and the LCM is 30. So here you have to multiply both numerator and denominator by 2. So what we will get here? 4 upon 30 minus, here you have to multiply both numerator and denominator by 15. So you get 15 upon 30. So here it is 4 minus 15. So what will you get? Minus 11 upon 30. So on left hand side you got 19 upon 30. On right hand side you got minus 11 upon 30. So you can clearly see that left hand side is not equal to right hand side. So even for rational numbers, subtraction is not associative. Now let us discuss multiplication. You already know that multiplication is associative for whole numbers and integers. Let us see for the rational numbers with the help of this example. So here I have taken 3 rational numbers. Minus 7 by 3, this is a negative rational number. 5 by 4 is a positive rational number. 2 by 9 is a positive rational number. Same rational numbers I have written over here, but I have changed the order. Here I am first multiplying these two numbers, and the result is being multiplied to this number. And here first we have to multiply these two numbers, and then we have to multiply that result with this number. So let us solve the left hand side first. So on left hand side we have minus 7 by 3, we'll write down as it is, and inside the brackets we have 5 by 4 into 2 by 9. So we can cancel 2 and 4, so we'll get here 2. So what we'll get here? Minus 7 by 3, then into 5 into 1 is 5, 9 into 2 is 18. So now you can straight away multiply because you cannot cancel anything here. So minus into plus is minus, 7 into 5 is 35. and 3 into 18 is 54. So this is what you got, minus 35 154 on left hand side. Now let us solve the right hand side. On right hand side, first we need to solve the brackets first. Inside the brackets we have minus 7 by 3 into 5 by 4, then we have into 2 by 9. So here you have to multiply 7 into 5. So what do you get? 35, and this minus into plus is minus. 3 into 4 is 12 in the denominator. Then 2 upon 9. You can cancel 2 and 12. You will get here 6. So what here you get in the numerator? Here you get minus 35. And 9 into 6, you got 54. So you can clearly see here that left hand side is equal to right hand side. Take some more rational numbers and check yourself, and you will observe that multiplication is associative for rational numbers. Let us write it down. For any three rational numbers A, B and C, we have A into in brackets B into C is equal to in brackets A into B into C. So for any three rational numbers A, B and C, multiplication is associative. That means you can multiply A, B and C in any order. On this side, first we are multiplying B into C and the result is being multiplied to A. You will get the same answer by multiplying A into B first and the result after that is being multiplied to C. You know that division is not associative for whole numbers and integers. Then what about rational numbers? Let us understand this with the help of this example. So let us check, is this side equals to this side? So let us solve first left hand side. So on left hand side we have 1 by 2 divided by, this is a negative rational number, minus 1 by 3 divided by 2 by 5. So as per the BODMAS rule, first we need to solve the brackets. So we will write down 1 by 2 divided by, in brackets, minus 1 by 3. Division changes to multiplication. Then you need to take the reciprocal of this number. So 5 will come in the numerator and 2 will come in the denominator. Now this is 1 by 2 divided by, minus into plus is minus, 1 into 5 is 5. In denominator you have 3 into 2 is 6. Same thing we'll do now. 1 by 2 division changes to multiplication. Now you need to take the reciprocal of this number. So 6 will go in the numerator and minus 5 will come in the denominator. You can cancel 2 and 6. So you will have 3 here. So in numerator you have 3 and in denominator you have minus 5. Now let us solve the right hand side. So on right hand side what do we have? On right hand side we have the brackets. So let us first solve the brackets. So when you will change division to multiplication, you will take the reciprocal of this number. So 3 will go in the numerator, minus 1 will come in the denominator. Let us write it down. So inside the brackets we have 1 by 2, division changes to multiplication. 3 will go in the numerator, minus 1 will come in the denominator, divided by 2 by 5. So here inside the brackets we have 3 by minus 2. Now we have divided by 2 by 5. Now 3 by minus 2. You change division to multiplication. You need to take the reciprocal of this number. So 5 will go in the numerator and 2 will come in the denominator. So in numerator you have 3 into 5. So you get 15. And in denominator minus 2 into 2. So you get minus 4. So on right hand side you got 15 upon minus 4. So you can clearly see that left hand side is not equal to right hand side. What does it mean? It means that division is not associative for rational numbers as well. Let us now discuss the role of 0. You know that 0 is the additive identity for whole numbers and integers. Let us understand this with the help of few examples. Suppose you have a whole number 2 and you add 0 to it. So what will you get? 2. Or if you add 2 to 0, what you will get? 2 again. So whether you add 0 to any number or any number to 0, you will get the same number. Similarly for integers. Let us take one example. Suppose you have minus 5. You add 0 to it. So you get minus 5. Or you add minus 5 to 0. Again you will get minus 5. So for integers as well, 0 is the additive identity. You add 0 to any number or any number to 0, you get the same number. Then what about rational numbers? For rational numbers also, 0 is the additive identity. Let me explain you with the help of one example. Suppose you have a rational number, say 2 upon minus 7. So here if you add 0 to it, what will you get? 2 upon minus 7, the same rational number. Or if you add the rational number 2 upon minus 7 to 0, you get 2 upon minus 7. Same thing. So even for rational numbers, 0 is the additive identity. Here we are adding 0 to 2 upon minus 7. So you got 2 upon minus 7. Here we are adding 2 upon minus 7 to 0. So you again got 2 upon minus 7. So we say that 0 is the additive identity for whole numbers, integers and rational numbers. So if you have any rational number, say a, if you add 0 to it, you will get a. Or you add a to 0, again you will get a. So we say that 0 is the additive identity for rational numbers. Now let us discuss the role of 1. 1 is the multiplicative identity for whole numbers and integers. Let us understand this with the help of some examples. Suppose you have a whole number, say 5. If you multiply it to 1, what will you get? 5. Or you multiply 1 to 5. What you will get? Again 5. So we say that 1 is the multiplicative identity for whole numbers. Let us take one example for integer. Suppose you have one integer, say minus 7. So minus 7 into 1, you will get minus 7. Or if you multiply 1 to minus 7, again you will get minus 7. So you can clearly see that whenever you multiply any number to 1 or 1 to any number, you get the same number back. What about rational numbers? For rational numbers also, 1 is the multiplicative identity. Let me explain you with the help of one example. Suppose you have minus 3 upon 4. If you multiply 1 to it, what you will get? The same number, minus 3 upon 4. Or you multiply 1 to minus 3 upon 4, again you will get minus 3 upon 4. So for any rational number a into 1 gives you a, or 1 into a also gives you a. So we say that 1 is the multiplicative identity for rational numbers as well.